This is the video lecture recording for Unit 3.7, right? Talking about graphs of the quadratic function. Again, we're going to have my calculator here on the left so that we can show you some math as we go along through this. All right. So looking at the overview for 3.7. The word quadratic comes from the word square, great, but when you're graphing a quadratic function, you don't draw a square, anything straight, right? And we talked a lot about this on day one when we were talking about quadratic, so hopefully a lot of this is just review for you or giving you more information, adding on to what you already know, all right? But quadratic functions are parabolas, which are those U shapes, right? And depending on, what that A value is or what the other parameters are, it's going to open up or down, it's going to be fatter or skinnier, right? And this is, we're going to learn all about how to draw these graphs in this unit. All right. So in 3.7, again, we're going to have two quizzes here. You're going to have a quiz on graphs of quadratic functions and then working with the discriminant. So you're going to have two quizzes here, one on the graphs of quadratic functions and one on working with the discriminant. All right, you're going to skip the 3.7 practice. Okay, if you would like, this could be extra credit if you want to do it, but otherwise feel free, please skip it and then move on to 3.8 when you're done with these two quizzes. But let's get rolling here with this study. All right, so graphs of quadratic functions, all right, they are parabolas. Again, this U shape, right? And they've got a lot of specific things in them that we've already talked about briefly here. But for instance, the vertex of the parabola, right? That's that bottom, that's that min or max point. It is where the parabola stops going in one direction and goes the other direction. So example for this one, it goes down, 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 hits this vertex, starts going up, 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 right? It changes. All right, there's also points on the graph. So points on the graph where it intersects the x-axis, also known as the roots or the solutions or the zeros. And those are where the y value, so the y value equals 0. All right, also we also a lot of times have this y-intercept here. That's where x is equal to 0 and we cross that y-axis. All right, but the three main that we're going to talk about, or I guess two main types of points we're going to talk about, is the vertex and the x-axis roots, these zeros, or what x-intercepts, whatever you'd like to call them. All right. Now it's really easy, in my opinion, to go from a graph and looking at the graph, but you've got to be careful when you're looking at the scale of things. All right, and I know sometimes it's really difficult to see these, so make sure that you zoom in and take a look. But if you look here, it's asking where the vertex of the parabola is shown. Okay, so the vertex of the parabola is over 1, down 9, so that makes that -1, -9. All right. And one of the first roots or zeros where it crosses the x-axis is at -4, 0. And this other one here is at 2, 0, right? X coordinate goes first, then Y coordinate. All right, so knowing those are going to be super helpful here moving forward. All right. On the next slide here, okay, again, talking about graphs of the quadratic function. All right, once we know our vertex, we have this thing called the line of symmetry, right? And it's that vertical line where basically if I decided to fold the graph right on that line of symmetry, it would make a perfect mirror image. So everything on the left is mirrored across this line of symmetry onto the right, okay? And again, the vertex can either be a minimum or a maximum depending on if the parabola opens upwards or if the parabola opens downwards, right? And that's going to be dependent on our A value on our quadratic. If our A is positive, it's going to open up like a cup. If our A is negative, it's going to open down like a frown. Okay, so to graph a parabola for given quadratic, okay, the x-intercepts, okay, this is a really, really big one here. All right, the x-intercepts are going to be super, super important. They're going to give us those values where we cross the x-intercept. So we've been working a lot on figuring out the roots, right, or figuring out the answers and the solutions to the problem, and now we take it that final step across the finish line and we can use those to now plot our graphs. Right, so for example here, if we have our equation y equals x squared minus 5x plus 6, okay, we substitute in 0, okay, so now we have it in our standard form. Okay, we can factor the expression using multiple ways, all right, now we know multiple ways, but we can factor our expression, okay, Now we use the zero product rule where we set both of those factors equal to 0. Now we solve for x. All right, we solve for x. And these x values now give us the x coordinate of our x-intercept. So I'm going to have one intercept at x is 3, y equals 0, and x is 2, y equals 0. All right. Moving forward here, okay, once the x-intercepts have been calculated, we can then graph them and we can find the vertex, right? So that min or that max point. So if we look at this example here, right, if I set x minus 3 equal to 0, I'm going to have x is equal to positive 3, which is why I have a point here at positive 3, 0. All right, same thing here. If I have x plus 1, if I make that equal to 0 using my zero product rule, okay, I can then figure out that I'm going to have a point at negative 1, 0. All right. And the final step is that the vertex of the parabola, its x value is halfway between the two x-intercepts, right? Because it has to be a symmetric graph. So it's going to be halfway between. And what that looks like here is this is what our graph looks like in 2D. If we move that, if we look at it in one dimension, you can see I've clearly moved over 2 steps from this first x-intercept and 2 steps from the second x-intercept, right? So it's halfway between both of our intercepts. All right. So mathematically, what that would look like here, again, if we start with our equation, right? We start with our equation and we factor it, we use our zero product rule, we end up getting our x-intercepts, right? So we end up getting our x-intercepts, right? I've got one at 1, 0 and 5, 0, okay? We then identify the x coordinates, so just 1 and 5, right? Just 1 and 5. What we can do then to find our vertex is we can take the average. So what you do to take the average is you add them both together and then you divide by 2. So our vertex here would be at x equals 3. All right, that's how we get the x coordinate for our vertex. Now, to get the y coordinate for our vertex, all we do is we plug back into our original equation and we solve for y. So when x is equal to 3, y is equal to negative 4. So our vertex for this equation here is 3, negative 4. All right. So moving forward with this one, the roots of this guy. So we have a negative value here, but a positive value here. So I'm going to have x minus something, and I'm going to have it multiplied by, again, x minus something. All right. Now, I know off the top of my head there's a couple combinations that are going to give me 24, but the only one that's going to add up to give me negative 14 is negative 12 and negative 2, right? So that would be what my equation would look like. And then I would have to take it that one step further to get my roots, right? So this is what it would start with. Then I would go to my zero product. So I would set both of these equal to 0 and I would solve to get my roots of x equals 2 and x equals 12. All right, so then if I were to plot them on my line, x equals 2 and x equals 12, right? Or 2, 0, 12, 0. All right, so then moving forward here, what statement below is true for all parabolas? And the answer is going to be all of them. Parabolas are symmetrical. Okay, the vertex lies on the line of symmetry, and the vertex is equidistant or equal distance from each of the x-intercepts. So all of those are true. Okay, so what we're going to do to find the x-intercept is we're going to take the average. So again, to take the average, we're going to do 12 plus 2, or 2 plus 12. Then we divide that answer by 2. So our x coordinate for our vertex is going to be at x is equal to 7. All right, then we just plug back into our original equation here. So I'm going to have 7 squared minus, let me make sure I get that down there, minus 14 times by 7 plus 24. So my y coordinate is going to be, again, I messed up here. Apologies. I've got 7 to the power of 2. 49 minus 14 times by 7. All right, plus 24. There we go. Apologies, I'm getting used to this new computer calculator. All right. So my answer is negative 25. So my coordinate for my vertex is going to be 7, negative 25. All right. And again, that's what that would look like. So I have my 3 points on my graph. I can then sketch a rough estimate of what my quadratic function will look like and the shape of my parabola. All right. So then you can not only use this equation to find the x-intercepts, but you can also use the x-intercepts to find our equation. So the whole time we've been working from equation to x-intercept. Now what I'm saying is if you have a graph and you have the x-intercept, you can actually work backwards now. Now you can work backwards and find out the equation from the graph and from the x-intercepts. All right, so for example, x-intercepts are x equals 6 and x equals 2. All right, and what we can do now is we flip the signs of our x values, and that's going to give us our two different factors, because if a is an x-intercept, then x minus a is that factor, right? X minus a is that factor, because when we're working in the forward direction, we set this factor equal to 0 and solve. So to undo that process, we now have to move our values, our a values, back to the other side. So I end up with x minus 6 because I'm going to subtract 6 from both sides, and x minus 2 because I'm going to subtract 2 from both sides. All right. Now, we can then use our FOIL method. Once we've gotten those two factors, we can use our FOIL method to get all the way back to our original quadratic. So moving forward here, if we start with the x-intercepts of the parabola, okay, if our x values are x equals 6 and x equals 2, the parabola is, we're going to assume it's a normal parabola. Okay, so x equals 6 and x equals 2, right? Again, to undo that, we take the opposite sign. So x minus 6 and x minus 2. All right, so how we can rewrite our equation is y equals x minus 6 quantity multiplied by x minus 2 quantity. All right, then the final step is we just FOIL this out. First, outer, inner, last. That gives us our original quadratic equation, right? It gives us our original quadratic equation. All right, so again, those are the summary of those different steps there. All right, now here are 4 graphs of different parabolas, okay? And if you click on these, you can see the different functions. So basically, if we zoom in, and let's zoom in on this one here. All right, so if we zoom in here, we've got a coordinate at -2, 0. Okay, so it's -2, x equals -2. But again, we've got to flip the sign. So that now becomes x plus 2. We have a other coordinate here at x equals 5. So again, we got to flip the sign. So it now becomes y equals x minus 5 and x plus 2. All right, then we FOIL this guy out and we combine like terms, and we can end up with this quadratic equation in our standard form there. All right. All right, so before moving on, we're going to show just a couple quick clarifications to help with the x-intercepts and the vertex. So showing the difference between if I have this equal to 0 and I have this equal to y, and that's going to show you the difference between a one-dimensional, right, a one-dimensional equation versus a two-dimensional. So just to show you here real quick, if we consider the following quadratic equation, right, we solve for x, okay, we solve for x, and then we find out that x is equal to 3 and x is equal to 5, right, by doing our factors and using our zero product rule. Okay, so that would take us to the two-dimensional answer here. Now, if I'm making this three-dimensional, I use y instead of 0. So when I move this to the three-dimensional, I can now form an entire graph, and that's how I get my parabola shape there. All right. And you'll notice something about the x values that you just found. Okay. You notice that the points that we found when we had our one-dimensional quadratic, okay? When we found those answers, those were the x-intercepts, okay? And again, as we found out, to find the parabola's vertex, we find the halfway point between the two x values, right? We find the halfway point between the two x values, which is 4. Then we plug in 4 into our original equation to calculate the y value. So we can then find our vertex as 4, -1. All right. And if we have those 3 critical points, we can pretty much estimate the rest of it in the general shape of our graph there. All right. So the 3 important points are the 2 x-intercepts and the vertex. All right, those are our 3 critical points. If you can find them, you can pretty much make any quadratic here. All right, the vertex is the, what is the vertex and how do you find it? All right, well, the vertex is the point that is either the very bottom or the very top of our parabola, depending on if it opens up or downwards. All right, and what we do is we find the x-coordinate by taking the average of our 2 x-coordinates for the x-intercepts, and then we find the y-coordinate by plugging them back into our original equation and solving. Right? And the x-intercepts are where it crosses the x-axis. Our parabola crosses the x-axis. And to find them, right, we change the y in the function to 0 and we solve our equation using the process we've been learning throughout this entire unit, right? We use our 0 product rule on our 2 factors and then we solve for our x, right? And that gives us our x-coordinate and our y-coordinates are 0, so then we can find our x-intercepts. All right. And again, I'm going to leave this one for you all to practice here, but it's going to be really key for you, again, to be able to factor. Okay, you've got to be able to factor these functions. And again, that's why we harped on it so long on that first day. We've got to be able to do these factors, right? But once you do the factors, you can solve for the quadratics and you can figure out what your answers are going to be. All right. Okay, so moving forward here, we'll skip this one for the sake of time. All right, moving forward here. All right, this is going to be very crucial for you with the quiz, and this one actually walks you through, a little bit less guided each time. So if I start here, find the vertex and the x-intercepts of the graph of the function. So obviously, we've got to set y equal to 0. We've got to factor. We've got to use our 0 product rule, find our x values. Those gives us our x-intercepts. From there, we've got to find our halfway point for our x-intercept, our x-coordinate of our vertex, right? And then we plug our x-coordinate back in to our equation and we get our y-coordinate for our vertex. All right, same thing here, except this one's a little bit already done for you. So our x-intercepts for this one are going to be x equals 6 and x equals 8. So x equals 6 and x equals 8. All right, then our vertex is halfway between, so we just got to double check to make sure, but our vertex is halfway between 6 and 8 means 7. All right, then I plug our 7 back in for x to calculate our y, and we should end up with a -1. So if I do this one for you, there you go, right? That our answer is B for this one. All right, and then finally here, this one's working backwards, working from graph out. So again, you've got your x-intercept at x equals -1 and x equals +3. Again, when you work backwards though, we've got to put those in our factors. So this factor goes from x equals -1 to x plus 1. This one goes from x equals 3 to x minus 3. Right, so I end up with an x plus 1 and an x minus 3. So this one should be letter B there. All right, so that's going to be really crucial for you and on your first quiz here. Now, briefly here, I'm not going to harp on this one for too long. Okay, we'll learn more about this later on in different units. But slope, okay, so slope, we talked about that a lot with linear equations. Basically, it is the steepness of the graph. All right, and we learned again a lot about that with the linear equations and the y-intercepts on that guy. So moving forward here with slopes. Oops, sorry, I went too far. Moving forward here with slopes, to remind you, it is the horizontal change over the vertical. Oh, sorry, apologies. It is the vertical change over the horizontal change, or how far it changes in the y direction over how far it changes in the x direction, right? Looking like this. Slope is, that little symbol there is delta. It means change in. So you could read this as it is the change in y over the change in x. Right? And what you're going to notice with a linear function, right, we talked about this, is that slope is going to be consistent, constant. It's going to be always consistent. But with the quadratic function, you're going to see that the slope is actually changing as we're changing our different coordinates. The slope is actually changing. So what's that all about? Right? And again, nonlinear functions, it's asking, do they really have a slope? Well, the answer is yes, they do, but they have a lot of different ones. Okay, they have a lot of different ones, which is something that you're going to learn more about when you take calculus here. But you can talk about this instantaneous slope here. Again, it's going to says right there, you'll discuss this in calculus, but I got to introduce it to you. Basically, instantaneous slope is a slope at one specific point. It's not for the entire graph here. So if we look here, okay, if we look, this instantaneous slope here, this first one, right, that is a really, really steep one. But if I'm looking here, I don't have any steepness to that, right? So my instantaneous slope for this graph is, again, going to depend on where you are looking specifically, okay, where you are looking specifically, all right? So in nonlinear functions, the average rate and change and the instantaneous slope are the same thing. That is false. They are not the same thing. The average rate of change is talking about the average across the entire graph versus instantaneous. Like I said, right here would be very steep, but right here would be non-existent. All right. So then moving forward here, okay, looking at the different slopes, what you're going to notice is that he found out that if we want to estimate specific points here, as the points get closer together, it gets a lot more accurate. So look, if I'm looking at the point 20, that's my first point. If I'm looking very far away, the average slope might be 5. If I start to get closer, it's going to get more and more accurate. So this one's getting closer to 4, 3.5, right? If I got even closer. So this is saying if I went from this first point here to 2.1. So if I went from 2.0 to 2.1, okay, it's going to be even closer. Maybe we'll say it's about 3.1, okay? And then the instantaneous slope at 20 is probably then going to be closer to 3, right? It's going to be closer to 3. And you can see that it's slowing down and it looks like it's getting closer to that 3 number. It's getting closer to that 3 number. All right. So what this means here, okay, is just fitting the different points of the function here, okay? So we have our quadratic functions, right? And we were able to calculate our x-intercepts and our vertex point. So moving forward here, though, we can figure out how to continuously plot the graph of the function. All right, so in this current graph here, the vertex is at 0.5 minus 4.5, okay? 0.5 and minus 4.5, all right? And this is going to make a difference here because when we look at our function, okay, when we look at our original function here, all right, so y equals x minus 2 and x plus 1, all right? What we haven't discussed is if there's another factor out in front. If there's another factor out in front, right? So for example, if our a value is not 1, we haven't discussed that. And this is why that slope comes in handy in talking about this, because we can have multiple graphs go through the same points, but they may not have the same slope. So again, did you forget about the functions? They all had the x-intercepts at the same thing, but we're going to try to figure out how they're different, right? And so again, how they're going to be different is that they're going to have different a values, right? So ax squared, they're going to have different a values. And how we can figure that out is if we look at the equation, we then put an a out in front. We put an a out in front. And we plug in using the values that we know. So we can look at the vertex of our current graph here. All right, we can look at the vertex of our current graph. When we plug that in, we end up getting a equals 2. So what we do is we multiply our entire factor by 2, right? So this is what's saying, you could call it a stretch, right? You stretched by 2, all right? Okay, for the other ones, you could do the exact same thing. So if you have something at x minus 3 and x minus 5, if it has a vertex at 4, -3, you would plug in those values. So you would say -3 is equal to a times by 4 minus 3 and 4 minus 5. So what that would look like if I simplified this down, -3 is equal to a times by 1 times by -1. Or -3 is equal to -1a. I divide both sides by my -1, so I have a is equal to 3. So what that means there is my graph is stretched by a factor of 3. My graph is 3 times larger, right? It's stretched out 3 times more because of this a factor, right? Because my original quadratic now has an a value that is not 1, right? It is not 1. All right. So earlier you saw how to factor quadratics, right? So we talked a lot about them, finding their roots, finding their x-intercepts, all right? And how do we use those to find the vertex, all right? Now, there's slight terminology difference here, okay? But they all practically mean the same thing. But just for clarity, x-intercept is the point on the graph. So if we're talking about x-intercepts, we're usually referring to them as being on the graph where they actually cross the x-axis. A solution is the value when we set it equal to 0 and it makes it a true statement. And then a root is a value that makes the polynomial equal to 0. So again, all effectively meaning the same thing, but have slight differences that you should be, at least familiar with. All right. Now, again, we talked about this in the last unit here. When we are solving for our x values, we're finding our roots, we're finding our answers, right? When we use the quadratic formula, we end up having a positive version of this and a negative version of this, right? Because it was plus or minus the square root. So we have a positive version and a negative version. All right. And even with these complicated looking roots, you can still find the vertex of the parabola by averaging the two values, right? We looked at it graphically and figured out, hey, if we take the average, we can do that. And we can do the exact same thing now, even though we're using this quadratic formula. And when we take the average of that, it ends up being you add the two together and you divide by 2, right? That's how we've been doing it. Take the average, you add them both together and you divide by 2. And what happens is the positive and negative square roots cancel out, and then we're left with this formula here. Okay, so when we add them together, we're left with this formula. But then when we divide by 2, it even is simpler. So to get a vertex, right, the x-coordinate, all we actually need to know is that x is equal to -b over 2a. Okay, so now when we're looking at this problem down here, we have our different components of our equation. So first off, 3x squared, so a is 3, correct. bx, so b is 6, and then the last one here is incorrect. C is not 2, C is 1, all right? Now, when we're calculating our vertex x value here, we're going to use this equation, -b over 2a. So we're going to have -b, which is -6 over 2 times a. A is 3, so we have -6 over 6, so that is true. Oops, sorry, wrong one. That is true. All right. Then when we take -6 and divide by 6, that gives us -1. So what we're going to do is we would plug that back in to our equation for the x value here, right? And be wary of parentheses, right? And so that would be correct. All right. So the only thing that was missing is that our c value is not 2, our c value is 1. All right. Moving forward here, if we look at an example, okay, so I can walk you through an example here. We identify a and b from the function, okay, so a is 3, b is 12, right? In order to find the vertex here, we use the equation x equals -b over 2a. So we plug in our values. We simplify x equals -2, so that's our x coordinate for our vertex value. Then what we do is we just plug that back into the original function. We simplify and we get our y coordinate. So our vertex here is at -2, -11. That would be finding our vertex. All right, here's another example, and we're going to skip it for time's sake. All right, now remember, we learned this in the last one, but we have the discriminant here is that b squared minus 4ac. It's everything under that square root symbol. All right. Now, if we have a positive discriminant, we're going to have 2 real solutions. If we have a 0 discriminant, we'll have 1 real solution. And if we have a negative, we're going to have 2 complex roots or no real solutions, right? So the complex one would be the number plus the imaginary number. All right. And again, when the discriminant is equal to 0, it simplifies as the following, right? So when we look at this, okay, if we have our discriminant equal to 0, it now becomes just our vertex, right? Just our vertex x coordinate. All right. And then if this discriminant is not 0, right, this last portion here is just moving to the left and to the right of our vertex, right, which is how it gets to be this very symmetric shape. So if we're looking at a couple examples when the discriminant is 0, right, the discriminant would be 0 because this is a perfect square. All right, this one's also a perfect square. This one's also a perfect square, right? And again, perfect square means the discriminant is 0, right? We have 1 real root. And when we have 1 real root, it only crosses the x-axis at that vertex point. Now, if we look here, if the discriminant is positive, right, it's going to be our vertex plus some number, or our vertex minus some number. So, example here, we're at our vertex plus some number, vertex minus some number. We're moving to the left and to the right. And the number that we're moving over gives us our x-intercepts. All right. Again, we could start here. Our x value equals 1, right? So it could be that -b over 2a, right, gives us 1 plus some number. Well, it ends up being that plus some number is 2, or minus that number is 2, right? So we end up being able to calculate our x-intercepts that way. All right. And then finally, when the discriminant is negative, right, we'll have our vertex plus some imaginary number. But since an imaginary number, you can't plot an imaginary number. You don't see them. We end up having no x-intercepts. So there is no x-intercept. No x-intercept. All right? It does not ever cross the x-axis. All right? Now, the quadratic formula can help you find the vertex and the x-intercepts of a parabola. All right, how do we use the quadratic formula to find the vertex? Right, we simplify it and we just look at what -b over 2a is, right? You can either look at the full quadratic, or you can just know that it's it's -b over 2a, right? And then what this says is it's the function of x, where x is equal to -2 over ba, otherwise known as plug the answer you get in for x back into your original equation. All right. What does the discriminant tell you about the graph? Right. Again, it tells us either we have 2 real, 1 real, or no real x-intercepts. All right. So if we look at a couple of these, we can do a couple problems together here. So the vertex of the function here, again, the vertex is negative b over 2a. So for this example here, it would be negative 4 divided by 2 times by our a value is 1, right? So our value is going to be negative 2. All right, our x value is going to be negative 2. Then what we do is we plug our negative 2 back in. So I would have negative 2 squared. Okay, negative 2 squared plus this calculator and I are not friends right now. All right, so I have negative 2 squared, all right, minus, I know 4 times negative 2 is 8, right, plus 4. All right, so I would be left with 0. All right. So again, doing another one here, the vertex of the function. Okay, so my x coordinate is going to be at that negative b over 2a. So negative b, so negative 8 divided by 2 times by 1. So negative 8 divided by 2 is negative 4. All right, then I would plug negative 4 back in here. So 16, I would have 16 minus 8 times 4. And since I have a negative and a negative, that's going to be a positive. So I'll have plus 8 times 4 plus 12 equals 60. All right, so I've got negative 460. All right. Moving forward with here, again, being able to answer questions about the discriminant, right? That is one whole quiz that you've got about understanding what the discriminant means and what that means graphically from your equation. All right, so if we look at this graph here, it never crosses the x-axis. So that means that I have no real solutions. If I have no real solutions, that means that the sign of my discriminant is negative. It's negative underneath that square root function. All right. Again, looking at these graphs, right? So if I looked at this one too, using the same question, I know that's not the question that this is asking here, but knowing that this has 2 real roots here, I know that my discriminant has to be a positive value. Okay, it has to be a positive value. Right, so you can tell a lot just by looking at these graphs here. Now, to solve this one, you can do multiple things. You can pick an x value if you want, plug it in and see if it matches with the y value, right? See if it matches with the y value. Okay, that's one way, but I would check multiple x values if that's what you're going to do. The other thing you can do is you can actually just factor this out, right? So factor, figure out what my x values are, and then that will give you your x intercepts, right? And again, process of elimination till you find the right thing. Okay, same thing. You can factor out here, find your x-intercepts. And if you have multiple graphs with the same x-intercepts, right, the next step then is to look at the vertex, right? The next step is to look at the vertex. All right. So again, this one is ending the first part of this lesson here. So we'll go on to the study guide and the concept check. All right. So for the study sheet here, for 3.7, all right, vertex of the parabola, it is the point where the parabola makes its sharpest turn, right? It stops going in one direction and turns and goes the opposite direction. It marks the center of the parabola. The parabola line of symmetry also passes through it, right? That line where if I folded it in half, it's a mirror image. All right, and then it's the halfway point between the parabola's 2 x-intercepts. All right, now, here, use the quadratic formula to find the roots of this answer. Okay, so first off, right, we got to make sure that this is in standard form. So I can change that to a 0, and then we're good to rock and roll here. All right, I use my quadratic equation, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. I can then plug in my values knowing that A is 2, B is 11, and C is negative 21. All right. I plug in and then I solve. Right. And I'm going to have a positive version and a negative version. All right. In this one, we're actually lucky because when we have the square root of 289, that gives us the number 17. All right. So I'll have 11 minus 17 divided by 4 and 11 plus 17 divided by 4. So that gets me my two real answers. All right. For the next one, find the x value of the vertex, right? So we're just looking at the equation x equals negative b over 2a. All right. Once we find the x value, we can then plug back in. Okay, we can plug back in and solve for the y coordinate of our vertex. Right, so then our ordered pair is obviously the x coordinate then our y coordinate. All right. This next main idea is that the y coordinate of any x-intercept is 0. Right, so in order to find the x-intercepts of a parabola, if we're not given the graph, like if we're given our equation, we've got to start with our equation in standard form. So again, if it's not in standard form, you change it to be in standard form. All right. We substitute a 0 in for y, right? We make the entire equation equal to y. Then we factor the trinomial, right? So we factor the trinomial. Example right there, we factor it using the numerous methods that we know. All right, we use the zero product rules to solve for x. So I set this one equal to x, this next one equal to x. Solve, I get x. All right, so then I now write my x answers as coordinate pairs. So this one would be 4, 0 and 2, 0. All right, moving forward here, the main idea, if A is the x coordinate of an x-intercept, then x minus a is a factor of the quadratic equation. So basically moving in the reverse direction from here. So knowing that x is equal to 4, I can work back and know, well, I had to get x minus 4 equal to 0. Therefore, that was a factor. Therefore, if I FOIL this guy out, I can get all the way back to my original, right? So that's exactly what we are doing. I've got a coordinate of x2 and x equals 4, right? So I have to change the sign. So this means that my factors are x minus 2 and x minus 4. All right, so those two are my factors. Then I'm going to use FOIL and I multiply them out. I combine like terms and I write the product then equal to our y. I write the product then equal to y. All right. 6 here. 6 is talking about using the quadratic formula to find the vertex. So for the parabola, okay, it's defined by the function ax squared plus bx plus c, and the coordinates of its vertex are this, right? And I know this looks very confusing. So basically what this is saying is negative b over 2a is my x, and then if I plug that in for my x value here, right? So again, I plug that in and I solve, that's going to give me my y coordinate. That's all it means, right? So how to find this? We identify a and b in the function, right? We plug it into our equation minus b over 2a, right? I plug that in. Then that gives me my x coordinate. I plug my x coordinate back into my original equation to solve for y. Once I solve for y, I write it as a coordinate pair, and that's my vertex. All right. And then finally, the last thing here is, again, redealing with discriminants. So if I have a negative discriminant, so that thing under the square root, the b minus 4ac, if that is negative, 0 roots. And what that looks like on the graph is it never touches the x-axis. All right. For the discriminant, if it's equal to 0, I have 1 real root. It touches the x-axis, but it will never cross the x-axis. All right. And then finally here, if I have a positive discriminant, I have 2 real roots, and it crosses the x-axis at 2 points, which is why I have 2 real solutions. Okay. Again, moving forward here, we're going to go to the checkup. All right, just reminding you, you only have to do these 2 quizzes. The practice here is extra credit if you want. And the first quiz is on graphs of quadratic functions. And then the second one here is about working specifically with the discriminant. All right, so moving forward with the checkup, we will walk through a couple practice problems. Again, work through the rest of them. Answers are posted on Google Classroom. All right, moving forward with the checkup. All right, moving forward with the checkup. We're going to do a couple of these problems here together, and I'll try to go through this quickly for you, but as detailed as I can. All right, so first off, find the x-intercepts of the function, right? So again, this is saying we're solving for x. All right, so first thing we have to do is we have to put this in standard form. So 4x minus 12, and I now set that equal to 0, and I'll zoom in for you there. All right, I set that equal to 0. So I've got two negative values here, and again, if I look at my p's and q's, right, I know I'm going to have x, and I'm going to have minus something and plus something. So the two things that I know will add together to give me negative 4, but multiply together to give me 12 is going to be negative 6 and positive 2. Right, so that's still equal to 0. Now what I'm going to do is I'm going to use my zero product rule and set both of these equal to 0. So x is going to equal negative 2 and x is going to equal positive 6. All right, so those are my two x values. So what those coordinates look like is negative 2, 0 and 6, 0. So those would be my final answers. All right. And again, it's specific. It says x-intercept. So that means I have to write them as coordinates. All right. Again, that's the knowing the slight difference between wording. So I have to write them as coordinates because that's what's asking for, the x-intercepts. All right. Now, moving forward here for the next question, 3 and 4, it's saying find the roots, right? So I'm just trying to solve for x. All right. So if we look at number 3 here, it says use the quadratic formula to find the roots. Now remind you, the quadratic formula, x equals negative b plus minus square root b squared minus 4ac. All over 2a. Yes, I know it's annoying that I keep repeating it, but I'm hoping that the more times I repeat it, the more you'll remember it. Okay, so first off here, we've got to set this in our standard form. Okay, so we're not even in standard form, so we got to subtract 15 from both sides. So negative 2x squared plus 11x minus 15 equals 0. Right, my a value is negative 2, my b value is 11, and my c value is negative 15. All right, so now I'm going to plug into my equation. So x is equal to negative 11 plus or minus the square root of 11 squared minus 4 times by negative 2 times by negative 15. All right, all over 2 times by negative 2. All right, so let's start simplifying some things. So I've got negative 11 plus or minus square root of 121. Oop, that is a minus sign because I've got a minus, minus, minus. So I've got minus 120 all over negative 4. All right, so we'll keep simplifying this here. X is equal to negative 11 plus or minus the square root of 1 over negative 4. All right, so sidebar, square root of 1 is equal to 1. So again, this is like saying negative 11 plus or minus 1 over negative 4. So I've got the positive version that I've got to do, and I've got the negative version. So plus 1 divided by negative 4. And x equals negative 11 minus 1 over negative 4. All right, so last couple of steps here. I know this is drawn out, but I want to make sure that I'm fully explaining myself. All right, negative 10 over negative 4, also known as 2.5, positive 2.5. All right, or x equals negative 12 divided by negative 4, which equals positive 3. All right, so those are my two answers. X equals 2.5 and x equals 3. All right, now for the next questions, it says find the vertex. Find the vertex, right? So we're going to use our vertex equation. Okay, we're going to use our vertex equation to find the x-intercept. Okay, to find the x-intercept. All right. So if we set this equal to 0, we know that our x-intercept for the vertex is equal to negative b over 2a, right? So my b value is 6 and my a value is 1. So my x-coordinate is going to be negative 6 over 2 times 1. So my x-coordinate is going to be negative 3. All right, my x-coordinate is going to be negative 3. All right, now to find my y-coordinate, I just plug back in my x value. So negative 3 squared plus 6 times negative 3 plus 8. Right, so I'm left with y equals 9 minus 18 plus 8. Y is equal to negative 1. So again, it's asking for the vertex, so I have to give it as my coordinate pair. So my vertex is negative 3, negative 1. All right, negative 3, negative 1. Okay. For the next guys here, all right, for the next ones here, we are looking at the functions and determining the functions. So the key things we need to look for are the x-intercepts, all right, the x-intercepts, all right, and so this right here is at 3, 0. Oh, sorry, not even 3. It's at negative 3, 0, and this one's at negative 1, 0. Right, and again, we work backwards. So if x is equal to negative 3 and x is equal to negative 1, all right, if I was to write this as my zero product sum, right, my zero product rule, I would have x plus 1 is equal to 0 and x plus 3 is equal to 0. So basically what I'm saying are my two factors are x plus 3 and x plus 1. All right, and if those are my factors, 0 is equal to x plus 3 times x plus 1. Right, I FOIL this guy out. So 0 is equal to x squared plus 4x plus 3. And then the final step is I change it from 0 to y. So that is your final answer there. All right. Oh, ha. All right. So for answer choices, sorry, I didn't even notice. I was very confused. All right. For answer choices, the first answer is correct there, right? Because it's x plus 3 and x plus 1. All right. And I took it a step further there by foiling it out. So apologies. All right. The first answer choice is correct. All right. Then this is the only one that they didn't really talk about in super detail. So I want to spend a little bit more time focusing on this one here. All right. Please, please don't get caught up in the way that they're asking the question, okay? It is not very difficult. Just understanding the question can be the difficult part here. So it says, what is the average rate of change between the equation y equals 2x squared minus 4x plus 6 between f2 and f4? So that's basically saying if x is equal to 2 and if x is equal to 4. All right? And it's asking you for the rate of change. And the rate of change is also known as the slope. So the change in y over the change in x, right? The change in y over the change in x. So if we calculate, what we'll have to do is we'll have to solve for y when x is equal to 2 and when x is equal to 4. Oop. So if I plug these in, okay, when x is equal to 2, y is equal to 6. All right. And when when x is equal to 4, y is equal to 2 times 4 squared minus 4 times 4 plus 6. Y is equal to 22, right? So my two coordinates are 2, 6, and 4, 22, right? So my rate of change is my slope, right? So I'm looking for y2 minus y1 over x2 minus x1, right? And so basically what I'm going to do is I'm going to plug in. So let's make this my second equation and this my first equation. So all I do is I plug in my second y value. So 22 minus my first y value, which is 6, over my first x value, my second x value, which is 4, minus my first x value, which is 2. So I've got 22 minus 6 over 2. And when I simplify this, I get 8. So my average rate of change here is just 8. All right, so to walk you through what we did again, to just walk you through what we did, f of 2 just means when x equals 2, what does y equal? So we solved for y and we found out y equals 6. So our first coordinate point was 2, 6. All right, f of 4 is saying x is equal to 4. So when x is equal to 4, we calculate y is equal to 22. All right, and then it says rate of change, which is talking about our slope. It's talking about our slope. So rate of change is equal to the difference between y2 and y1 divided by x2 and x1, right? So I just took my coordinates. This is my second coordinate pair, and this is my first coordinate pair. So y2, x2, y1, x1. I found out my slope or my rate of change is equal to 8. All right. Again, there's more problems for you to work on if you'd like. Take a look. Rewatch the video if you need extra practice, and make sure you do both of those quizzes, and you can skip the practice or use that as extra credit.